This is our agenda. There are a couple of things we're not going to talk about today because we've dealt with them elsewhere in the past or will be dealing with them in the future. But I just want to mention a couple of very important security facilities that we won't have time to deal with today. What we will be covering with today, I want to go through the process of authentication with digital certificates. That's one way of logging onto the database without having to present a password, because that's what this is all about. Ways of logging on without needing a password or without needing to present a password. First one, digital certificates. Everybody loves and hates digital certificates. We love them because we have to use them. They make the internet secure. We hate them because they can be such pigs to work with. So authentication with digital certificates. Then we'll move on to proxy authentication. Proxy authentication introduced in release 9, but to this day, I'm often surprised at how rarely it's actually used. You may be using it already without realizing it. It's used, for instance, by Apex as the method for managing the connection pools. But I often find it isn't used as widely as perhaps it should be, even though it isn't new. It goes back a while. Similarly, the Secure External Password Store. Very nice facility for transparently logging people on without having to present a password. Very easy to set up, totally Oracle proprietary, of course, unlike, say, using digital certificates. It's Oracle proprietary mechanism, but is very useful indeed, particularly for your scripts and your batch jobs, perhaps called by cron or whatever, where you don't want to embed passwords within them. We'll have a quick look at operating system authentication. Some people will say that operating system authentication is dreadfully old-fashioned and not really for the 21st century. I disagree. There are quite a few cases where it's very useful. Okay, the Secure External Password Store may be better, but operating system authentication is still a perfectly valid and fully supported technique. And at the end, a very brief word about schema-only accounts. That's really because it's come up when running training courses and discussions about what on earth are they for. So I'll try to describe what a schema-only account is. Basically, it's one that can't log on at all. The items we are excluding from today's discussion, firstly, real application security. Real application security is a very powerful capability. We did a webinar on it a while back and a couple of pre-recorded tutorials as well. Within the database, it's almost like a connection pooling mechanism managed within the database. You have a whole set of users which connect to the same schema. So in terms of who will you see in the DBA users view, you'll see one user, one schema. But at the real application security level, there are many, many users who are known to the database mapped onto that common schema. It's a very powerful capability implemented purely within the Oracle environment. The other item we don't have time to talk about today, but I certainly want to highlight for future research, is the use of LDAP, your Lightweight Directory Access Protocol, and using LDAP directories for authentication. We come across that with great frequency with many of the clients we work with, typically using Microsoft Active Directory and Kerberos for the authentication mechanism. But it's a bit more generic than that as LDAP authentication, and it doesn't have to be just Microsoft Active Directory. There are alternatives. But it all relies on the same concept that the authorizations and authentications are delegated to an external directory service. So you authenticate to the directory, get tokens or whatever. Those tokens are presented to the database. The database will say, who on earth are you? Go to the directory, find out who you are. And also, if you've configured it, find out your roles, your privileges, what you're allowed to do. So very nice capability indeed. I should emphasize as well that both real application security and LDAP authentication, they can both be used as Apex authentication schemes. Far more powerful and versatile authentication schemes than the native Apex authentication, where the user accounts are all maintained within the Apex environment. So just pointers for further research, real application security and LDAP.
John, just FYI, I put the link to the real application security tutorial in the chat.
Thank you for that. I knew it was somewhere. Good. I'd encourage you all to have a look at it. It was a good webinar. We went through that. It was a lot of work with our Apex people to make that functioning, to see how well it can be used. So moving on then to what we are going to talk about. Digital certificates. Now, forgive me if you know all this backwards already, but just to make sure that we are all on the same page with the manual, as it were, what can a digital certificate do? And secure sockets in general. A certificate can do three things. It can provide the keys for public and private, public-private key encryption, which encrypts your traffic against interception. So basically it protects your data on the wire. So if anything's intercepted on the wire, it will be encrypted using the PKI tools. Encrypt with the private key, decrypt with the public key. It protects you against your data being intercepted. The second thing it does is integrity checks. Even if your data can't be read because it's encrypted, it could still be tampered with. It could still be damaged. Perhaps damaging a transaction is as bad for your environment as having the transaction intercepted and read. And the integrity checks, typically based on SHA type algorithms, are also part of the SSL implementation with digital certificates. But the third thing it does, which is what we're talking about today, is it can be used as a means of identification. You can present a certificate to prove who you are. And what we are going to do is configure the database to accept a certificate as a means of authentication. Both the client and the server will need a certificate. So the server can authenticate to the client can authenticate to the server. For encryption, you don't need certificates both sides. But if you're using certificates for authentication, you'll probably want certificates both sides. You typically also need the trusted issuer certificate, because anyone could make a certificate. I could make a certificate that says I'm the Queen of England and present it to you. Doesn't mean I'm the Queen of England, not by any means. The certificate needs to be issued by a trusted authority. One of the small number of companies that have got themselves into that wonderful position where they can sell you certificates and everybody trusts them. And of course, they're ones who do it for free, like Let's Encrypt. So you need not only your own certificate, you will need the issuer's certificate as well, so that the service you're contacting will know that not only are you okay, they know who you are, but also you're authenticated by someone who they trust. What will then happen is the database will look at your certificate, read the distinguished name, the DN within it, and use that distinguished name to map your session onto a schema. How's it configured? SQLnet files. This is all done at the SQLnet layer. We have entries in SQLnet Aurora on the client side that will tell the client where the certificate is. We'll have entries in the listener Aurora that will tell the server where its certificates are. I should emphasize, by the way, clearly this does rely on the operating system being secure. If your operating system is insecure, maybe you're using, I don't know, a PC, and you're logged onto the PC, you've got your certificates there, you use the certificates to authenticate to a database. Well, if you then walk away, leaving your PC logged on, to take a ridiculous example, someone marches up to it, puts in a memory stick and copies your certificate, well, then they can impersonate you. So this does rely on the operating system being secure. That shouldn't be a problem if you trust the operating system, which I think we should all do nowadays. So let's configure it. Yes.
Quick question before you continue. Is Oracle charging for SSL in the Oracle database these days?
Not anymore. It used to be part of the advanced security option, but for a few years now, they've removed the SSL authentication. Obviously, when it comes to licensing, don't anyone ever quote me. If I understood licensing, I'll be a salesman rich instead of a technician and poor. But to the best of my knowledge, SSL authentication is no longer a chargeable option. It's there even in standard edition, but don't quote me on that, do check.
Likely the case. Thanks, John.
Now, let's configure it. In this demonstration, by the way, I'm going to run both the client and server off the same Oracle home. That's just for speed and ease of demonstration. So that's just a minor point. I'm running off the same Oracle home, client and server running on the same machine. And that will simplify the number of certificates I need. In practice, of course, the clients would typically be remote machines, many clients on many remote machines, each with their own installation of the Oracle client. The instant client will do. Now, Oracle expects certificates to be in a wallet. So I need to create a wallet to store the certificates. So I'll begin just by creating a directory. I shall just call it wallet. And that's where my wallet is going to be. Then we have the Aura PKI facility. The Aura PKI utility installed in your Oracle home, client home, server home. It's shipped to pretty much every Oracle product there is nowadays. The Aura PKI utility is what I'm going to use to create and administer the wallet. Now, to create the wallet, Aura PKI wallet create. The syntax of this tool is a bit of a nightmare, but the online help is pretty good, and there are all sorts of examples. I'm giving you some examples right here. So the command I'm using is going to manipulate a wallet. What am I going to do it? I'm going to create a wallet. Where will that wallet be? And I point it towards the directory that I've just created. I'm making it an auto login wallet. If it isn't an auto login wallet, every time you need to extract a certificate from it, you'll need to provide the password, which rather obviates the point of not needing to provide passwords anymore. So nearly always you will want your wallet to be auto login. And there, I'm sure you can see the significance of the operating system being secure. Now, if you're logged onto Unix or Windows, you've got access to those certificates because it's automatic login. It does, however, have a password. So to change the contents of the wallet, to manipulate the wallet, you will have to present that password. So if we then look at the contents of the wallet directory, that's just created the wallet. Two versions. There's the international standard version of the wallet, and there's the Oracle proprietary auto login version. So the C wallet, because I've got both types because I said auto login. Now, then I need to get a certificate into it. So let's pretend I'm the client. You could buy your certificate and VeriSign or whatever and upload it into the wallet. But for now, I'm going to use a very simple technique. I'm just going to create a certificate. Or a PKI wallet add. And that's the wallet I'm going to add the certificate to. And that's the password to open the wallet. The next switches here are going to generate a self-signed certificate. In the real world, you will probably be uploading a certificate that you've purchased. A certificate has a distinguished name. Generally speaking, you'll be using the name of the machine, probably. And that's what I've chosen here, the name of my machine, which is just an IP address and ec2.internal, name of the machine, and the certificates will be valid for a year. There's the key size, 1 kilobyte, and most importantly at the end, self-signed. So I'm creating a self-signed certificate. And that will be put into the wallet, which we can see here. Or a PKI wallet display, minus wallet, home Oracle wallet. Note you don't have to provide the password to display the contents of a wallet, only to manipulate the contents of the wallet. And this is what you will be wanting to see. You will see one or more user certificates, and that will be the certificate you bought from Thought or VeriSign or any of the other companies or have acquired from Let's Encrypt. That will be the user certificate that you are going to present to servers to prove who you are. We also have the trusted certificate of the certificate issuer, and that will be the one from DigiCert or VeriSign or whatever it might be. So typically there'll always be at least 2 certificates, one or more user certificates, one or more trusted certificates, authority issuers certificates. In my case, because it's a self-signed certificate, they are basically the same. So that's got the certificate created. Now, having got the certificate there, I need to configure the client and the server to use it. So I shall start. Yeah.
A couple of quick questions. Kelly's wondering, a Willow version 12.1 wallet can be copied to a 19.3 database. Will that work, or should it be recreated?
It will probably work. It might well work. If it doesn't, there's an upgrade facility. But I have managed to use wallets across releases. I don't know if I'd actually recommend that. I don't know if I'd recommend it. You might well find that some of the more sophisticated cipher suites, for instance, might not function with an older wallet. So, good thing would be to either upgrade or recreate.
And is this the certificate for the server of the client you just created?
In my case, I'm running them both off the same Oracle home. But you would do this twice. You would have one wallet for the server and one wallet for the clients. And of course, in many cases, you'll have many clients on many different machines. So the server will need a wallet, the client will need a wallet. They'll each need their own certificates. In this example here, I'm running them off the same home, so one wallet will do for both.
Right. And finally, you're demonstrating to us on Linux, clearly. What about support for, let's say, Windows?
It works. It works. I've often had problems with Windows, but they're largely due to my ignorance of Windows. Issues with permissions. It's things like when you create your wallet, it'll probably be created under the account of your Windows logon. But when an Oracle product, such as a database server, reads the wallet, it'll be running under the account of the Windows service owner. And many times I've had problems with accessing wallets for that reason, which is not a problem with Windows or a problem with wallets. It's a problem with the way I failed to configure Windows security correctly. It's that strange issue that you are not the same person as the account under which the database service is running. So yes, it works under Windows, but you may need help from your Windows system administrators to get it working correctly. Okay. If that's all, let's configure it.
Sorry, John. Yes, it was. I had myself muted. Thank you.
Okay. Server-side configuration. Listener.aura. I have to tell listener.aura, tell the listener where the wallet is. Right. And that will be with command and entry such as this. Oops. Right click, copy and paste. So I'm telling Oracle's listener the wallet location. The wallet location is going to be a file. It could be an LDAP directory. Under Windows, theoretically, it can be the Windows registry. Again, I've had issues with that. But most commonly, the wallet is a file. And because it's a file, I tell it where it is. That's told it about the wallet. But then I need to create a listening address. Because at the moment, my listener is listening on that address, port 1521, for TCP. I need to add another listening address. And the listening address I'm going to add is, actually before I do that, before I make too many typing errors, I'll just comment that line out. Just get rid of that. And I'll copy in a whole new line rather than make too many typos. So what I'm adding here is a second listening address. So I've got my normal TCP listening address on port 1521. I'm adding a second address for TCP-S on port 2484. You can choose any port you like, but Oracle generally uses 2484 for TCP-S database listeners. So we create a listening address for TCP/S. We tell Oracle where the wallet is. Save. So at this point, my listener is listening only on TCP. Shut it down and restart. And now you see we've got the TCP/S address as well. So that's the server-side configuration. The server can find its wallet, is listening for TCP/S. Now, jump to the client-side configuration. That's all done in SQLnet.aura, because of course the client doesn't have a listener.aura. So the SQLnet.aura file, at the moment all I've got is authentication services, BEQ, nothing there at all. So I need to add to my authentication service, I'm going to permit authentication with TCP/S, as well as the standard bequeath handoff, or NTS if it were Windows. To enable TCP/S as an authentication service, tell the client where the wallet is, with the same syntax we use in listener.aura, and then add another line. SSL client authentication equals true. So this will configure SQLnet then to authenticate clients over that protocol with certificates located in there. And what's the final file we configure for SQLnet? TNS names. So again, client side, I need to add an entry that will go to the TCP/S listening address. And there it is. My alias ORCL SSL will go to the listener on that port using that protocol. And because of those SQLnet.aura settings, it will put through the certificate. Final bit, bring it into use. Log on to the database. There's someone reasonably highly privileged, and create a user. Nice bit of syntax here. What we will do is create user JW, identified externally as, and there's a distinguished name, CN, or common name in this case, equals that. If anyone presents a digital certificate that says this is who I am, we'll connect him to that schema. Better allow him to log on. It's a perfectly normal user, for it's just the identification identified externally that's different. Can I now connect from the client? SQL+ / at the TNS names alias, remember, was ORCL SSL. Straight through. Who am I? JW. It's that simple. And that syntax will work in shell scripts, batch file, anything you like. And the database will have absolute confidence. It knows who you are because you presented that certificate. And the final proof, I'm looking at the network protocol used. Yes, indeed, I am using TCP/S for my session. It's a very nice way to connect, to authenticate, without any need to know passwords, to expose passwords. You can't lose your passwords. You can connect from any machine where you have your certificate. Or if you store your certificates in an LDAP directory, you can connect from any machine where you can connect to the directory. Very nice indeed. And there's none of this hassle of passwords expiring either, which is a perpetual problem at many sites.
John, is setting the procedure the same for a JDBC thin client, do you know?
Yes, it will work that way as well. You can use it with JDBC thick client, the OCI libraries, and that's in effect what I'm using, all OCI. The thick client, no problem at all. JDBC thin client, it does work as well. I personally haven't done it. My understanding is that Oracle provides all the classes that your developers need to make thin clients work. So we are reasonably non-proprietary for the way it functions. Okay, let's move on.
Pardon, John, one last question. The create user command you used to identify externally, cn equals IP, blah, blah, blah. Is that the name of the certificate?
It's not the name of the certificate, it's the name embedded within. Oh, hang on, well, let's have a look. If we go to looking at the contents of the certificate, there you see it's the subject. The subject, the name is a bit ambiguous. It is the subject of that certificate. So if we present a certificate where that is the subject name, then we get mapped onto that account with that bit of syntax. Okay. Now, proxy authentication. I love it. The analogy is the Unix SU command. There are any number of occasions where DBA will kill for the equivalence of the Unix SU command, well, there isn't one. But this is very, very similar, gives you a very similar effect. All those occasions, this is speaking to the DBAs among us, all these occasions where you want a user has got a problem, something's gone wrong. When I say a user, it could be a pooled connection, but something's gone wrong with some session logged on as someone. And you try to do whatever it is, and it works. It works for me, but not for him. What do you do about it? You need to become that user to see what the problem actually is. Well, if you know the user's password, no problem. You just log on as him. But let's assume we don't know the user's password. And of course, no user is going to tell you his password. You know, if a support person asks you your password, you're meant to put down the phone immediately. We don't do that anymore. Within the database environment as a DBA, you can, of course, change the user's password to another value, log on using that password, and then there's that undocumented syntax, alter user identified by values, to set the command back. But that's a pretty horrible workaround and will cause all sorts of problems for users, while you're doing it. This is much, much better. We use your own credentials to connect to another user. Right. And you really do become that user. You take on you attach their schema, you take on their identity, including their security context, their complete security context. I say complete. Roles, you can selectively enable only certain roles through this mechanism, but by default, all the roles the user has will be available to you when you connect through this mechanism. It's really useful for database administrators. As a by the by, it does underpin the Apex session architecture, the way Apex connection pools work. Sometimes I get asked, what about the command alter session set current schema? That doesn't have the same effect at all. Now, alter session set current schema doesn't change your security context. You're still you. You just happen to be appending a schema name to all object references. It changes the name resolution context, but not your security context. So let's do it. I'm going to work under Windows for now. So I'll connect as a high privileged user system. Right. Now, one of my users in this account is the HR schema. And I've got the usual select star from HR.regions. We've got the normal spelling mistake. Right. What I shall do is enable proxy authentication. Let's pretend I don't know HR's password. Alter user HR grant connect through system. That's the syntax. I can now do this, connect system, square brackets HR, close square brackets, and present system's password. Right. Who am I? I'm HR. Oh, I could equally well, of course, have gone across the network. No difference. So that's it. We alter the destination schema to allow, in this case, system to connect through it. And this is just wonderful. I really am HR. Now, if we look at what roles I've got, select staff and session roles, resource and SODA app. If you look at my privileges, I've taken on HR's privileges. So I really am him. I can do whatever I like and get a realistic impression of what's happening. I use this all the time when assisting our developers and external clients. All the time.
John, what about through database link?
Oh, good luck with that. I did wonder if that would come up as a question, and I was just doing a bit of research beforehand. I do prepare for these webinars. Database links are a real problem, and I was just researching this. I found this article, for example. Let me make that a bit bigger. Didn't quite expect whatever happened there. Oops. Right. Bug here, proxy database link fails from 11.204. So database links and proxy users. Well, this is one of those most annoying articles in Metalink. Starting from 11.204, proxy database link fails. It doesn't work from 11.204. And they actually claim that it was never meant to. When it did work, it was incorrect. And if ever there was a way out of fixing a bug, it was that. However, it seems that people were really furious, and there is now an event you can set. So yes, it can work through database links. And theoretically, they say the fix includes from 12.2, but it didn't work for me last time I tried it. So with regards to database links, theoretically, yes, it used to work. You may have problems. Try this and let me know. Okay. As an example of how one might use it, say if I were to use the, let me go to, I'll just show you very quickly. I am aware of the time. If you take a look, for example, at an Apex environment, I'll just make that display a bit bigger, change the settings, and put the font size up. Okay. Sudo su minus Oracle. This is just a database we use for one of our teaching environments. If I log on to an Apex container, for example, the view that shows you our proxy authentication is DBA proxies. So select proxy clients from DBA proxies. And what this is showing me is that in a standard Apex environment, the aud public user, and possibly one or two others, have been given the ability to proxy to these schemas. So these schemas we see here, known as clients, these are the Apex parsing schemas for all your workspaces. These are the parsing schemas. And when auds, the aud servlet logs on, it will log on as this guy. And he has very low privileges. If you look at the privileges aud's public user has, all he's got is create session, absolutely nothing else. But he then has the ability to proxy to these users, and these are the parsing schemas of your Apex workspaces. So you may well be using proxy authentication, whether you know it or not. Right. Okay.
John, can you share the doc ID of that Metalink doc you had?
Sure. There are quite a few. There are quite a few on these lines, but I do realise this might save a bit of time. I'll put that into the chat there. Oh,
thank you.
Dave, I think that's gone only right. Thank you. Now, operating system authentication. Just a very quick word, a brief word on this. It still works, still fully supported. There are some issues, however, with multi-tenants, and that's why I suspect it may be falling into disuse. remote OS authentication is officially deprecated. But the general idea is you log on to Unix or Windows to authenticate to your operating system, and then your operating system ID is passed through to the database. In the old days, we used to use it all the time on the mainframe, for instance. You'd log on to your IBM system, you'd authenticate to RACF. Well, RACF is unbreakable. And once you've logged on to RACF, why do you need more authentication? Just pass that ID straight through to the database. Nowadays, we tend to use less secure systems like PCs and Macintoshes and so on. So it tended to fall into disuse, but it's still very useful indeed, typically for running on servers, not for remote authentication. Useful for scripts called by cron, perhaps, any environments where you don't want to have to worry about passwords expiring, where you don't have to want to embed passwords in scripts, expose them in any way. You rely on the operating system to authenticate to you. I'm going to do a very quick demonstration of it under Windows. And the reason I'm doing that is under Windows, it can be a bit awkward. So I'll take a risk and see if it works. First off, in your listener.aura file, you must have enabled, let me improve the font on that, font, push that up. You will need authentication services set up. NTS for Windows, BEQ, bequeath, which is the default, in fact, for Linux, Unix. You'll need authentication services configured there, which I do have. Right. Now, the question I find where it can be awkward, who on earth am I as far as Windows and Oracle are concerned? The results are sometimes a bit odd. So if I log on, I'll actually connect as user Scott, Tiger. And who am I? Well, select OS user from read all session. My username equals Scott. That's my operating system ID. JW/John. Why is that there? Because who am I? That's who I am. And this is using a local account, not a domain account, of course. But you need to be aware of that you need to be absolutely sure of who you really are. And domain accounts can confuse that quite a lot. I've also noticed issues with case sensitivity. There's a parameter as well called OS authent prefix, defaulting to ops$. You can set that to null if you wish. What Oracle will do for operating system authentication is prepend that, if it's set, to your operating system ID, which is that, and map you on to a database account with that name. So to create a user, bit of syntax, create user ops$, which is that prefix, JW/John identified externally. Note the case sensitivity. I learnt the hard way. Even though that is showing as lowercase, that needs to be uppercase. You get these odd anomalies under Windows. Note the use of double quotes, because a dollar is not a legal character. Well, no, I think it's that slash. That slash is not a legal character for a normal Oracle name. So that syntax should work. Give him the ability to log on with, I'll just grant him the connect role. Grant connect to ops$, hit again the double quotes. And what happens now? SQL plus slash, hey, I'm logged on. Who am I? That's who I am. Very useful indeed. A very quick and easy way to do it. However, it has to be said, these alternatives may be better. Certificate authentication, we've already talked about, and the external password store, which we'll talk about very soon.
John, you have mentioned to me, or implied at the very least, that auditors don't like this. Can you expand on that?
I've noticed quite a few of the audit and security checklists, things like the checklists from the Center for Internet Security, for instance, they throw up warnings if you're using operating system authentication. As to why, I'm not sure. I suspect it may just be that these two are considered to be better. It seems to me that operating system authentication is solid. but you've got to trust your operating system. And I've noticed a few of the security checklists say, don't do it.
Thanks, John.
Okay.
Hey, so while John just gets a quick glass of drink of water here, just 30 seconds about our services. Don't forget that John leads up our Oracle Database Administration team, and we would love for you guys to hire us to help you with a project, large or small. Small tasks you could offload, clear some room for your own team's bandwidth. That can include database upgrades, database installations, Apex stacks, designing that either on-premise or on AWS or Oracle Cloud. And I mentioned before that, mentoring has become really quite a popular service. So you're getting the training and some hands-on with your environment, be it a development or test environment as well. And of course, tuning, we're pretty handy there at tuning. You should see John's tuning capabilities. And by the way, we have some great, yes, Chris, it is time for a pint over there in England. But we have some great tuning, SQL tuning and how to read explain plans out there on the tutorials that I sent the link to before. So you should be able to get some benefit from those if you haven't already. So John, as long as you haven't already gotten into your pint, back to you.
Thank you, Dave. Now, so the last major topic today, the secure external password store. Now, this is a way to add a password to a connect string transparently. As far as the database is concerned, it's an absolutely ordinary logon. The database receives a username and a password, normal routine, authenticates you, your session is established. So for the database, it's just a perfectly normal logon. All the configuration is on the client. Within the client, we configure a wallet, yet another type of wallet. In that wallet is stored your password. And when you issue a connect request, the password is extracted from the wallet and appended to your connect request. Right. So it's all done by TNS names aliases. It works for interactive tools, it works for scripts, scripts called by cron or whatever. It works for anything basically. And the passwords never need to be exposed. The end users create their wallets, the end users manage their wallets, the end users manage their passwords. If the password expires and has to be changed, we change it in the database, the wallet won't work. I have to change the password in the wallet as well. So as far as the database is concerned, it's an absolutely normal logon. All the work is done on the client. The users manage their own wallets. So let's do it. It's done in SQLnet.aura. First off, though, I have to create somewhere for the wallet to live. So on my Windows machine, mkdir/tmp/secure store. That's just a directory where I'm going to put my external password store. Then I need to tell my client, oh, it already exists. Just delete whatever's in it. Make sure I've got no rubbish hanging around. And let's create a fresh one. And yes, that's emptied anything since. So I've got an empty directory for my wallets. There it is. I need to tell my local SQLnet.aura where the wallet actually is. So notepad, percent %/ network admin SQLnet.aura. Work. Spelling. Right. And I need to tell my client side then where the wallet's going to be. So an entry would be this. Wallet location equals source, method file, method directory, TMP, secure store. SQL.wallet override, I'll come to that later on. But those are the two entries that will allow my clients to read passwords out of the secure store wallets, the external store. File, save. So it's purely client-side configuration. Then my end user has to create the wallets. The utility, mkstore. And mkstore is just installed into your Oracle home on the client side. So, syntax, mkstore minus WRL, the wallet resource locator, tell it where the wallet's going to be, minus create. And I get a prompt for a password to protect it. And if we now look at that wallet, dir/tmp/secure, there it is. Notice always auto login. The default is auto login, which of course is the whole point. You don't want to have to give a password. So I've got my wallet created. Then I need to add a credential to it. Well, SQL plus Scott Tiger at, oops, I'll go across the network. Scott Tiger at ORCLZ. So I go across the network to the database, and my password is Tiger. So I need to embed that in the wallet. Here's an example of the command. mkstore again. So I've already used mkstore once to create the wallet, which I did there. Now I'm using mkstore to create a credential in that wallet. And the syntax is, when you go to this TNS names alias, if connect to Scott, and that's Scott's password. So for that TNS names alias, I've embedded username and password. And they are written out to the wallet. Password, and that's the wallet's password, mark you, which was specified when I created it, and that's written it. And there's another little command where you can see what credentials you've got. That's the list credential, password again, for the wallet. And I've got a credential for that TNS names alias, there's a credential for Scott. And what your users will be doing, if they've got logons to 50 databases, they'll just create 50 TNS names aliases and embed the username and password to use for each one. And they'll get all 50 listed out like that. And it's really brilliant. Now, all my user needs to do is this, SQL plus /@ ORCLZ. No username, no password. That syntax tells Oracle, go to the wallet and get the username and password to use when connecting through that. And there I am. Right. You may remember from our first demonstration, that's identical syntax to using secure sockets to presenting a certificate. So that syntax is identical to the SSL certificate syntax. And that is why we have that. That tells the client, if you see that syntax, go to the secure password store wallet, don't go for a digital certificate. Right, so that's just a odd bit of syntax there, because when you look at this, you don't know which one you're using. And this is brilliant. It's a really quick and easy way to automate your logons to everything. Do remember, of course, that it's an absolutely normal Oracle password. When it expires in the database, your wallet won't work anymore. But overall, very nice facility.
John, scenario, what if you add multiple users with multiple passwords to the wallet?
You can certainly do it. That will mean multiple TNS names aliases. So if you have 10 logons with 10 usernames and 10 passwords to the same database, you'll need to create 10 TNS connect strings going to the same database. It's no big deal.
Makes sense. There's a new parameter. Bear with me 1 second. I had it. I just lost it. That new parameter is wallet_root. Can you talk to me about?
That's a good question. That's a good question. This came in release 18. We've got that wonderful parameter, wallet root. And that, configured in the database, means you don't have to mess about with SQL files and listener files. The database itself can be made aware of where your certificates live. It doesn't apply to this one because this is a client-side utility. But this parameter, we've got another undocumented one, that's undocumented still. But this is another way of configuring the server to locate wallets without having to use SQLnet files. Doesn't apply to the clients. Okay.
Thank you.
Have we time for a final quick topic? I think so, just. Schema-only accounts. This is really just something I threw up by popular demand. What on earth is it actually for? Right. You can create a user without any authentication at all. This came in release 18. So you can't log on, except via proxy. Proxy-only accounts were actually introduced in release 12 point something. It's all about creating a structure for an application. This is used by many third-party products and included by EBS. The idea is, in your application, you have a set of schemas that typically contain only data objects, your tables and your indexes. In eBiz, it's one schema account per module, so there are a couple of hundred of them, not 300 nowadays. So you have these schemas that are just data containers, Then you have another schema that contains your programmatic objects. In the case of eBiz, it's the app schema. And in that app schema, that's where you have your views, your procedures, and your synonyms that point to the objects in the schema-only accounts. So your procedural object schema has all the permissions needed to get to the data objects. And the data objects are completely protected. You can get to them only through authorized code. And from release 12 onwards, you're probably using code-based authentication. You're granting roles to procedures. So your end users have no privileges at all. All they have is execute permission on a procedure in a shared public account. And that procedure has privileges through roles on objects in the data schemas. That's a fairly common and fairly common way to design applications nowadays. Well, the way we used to do it before was creating these schema-only accounts, and you'd then expire the password. You'd lock the account and expire it. Well, that was a kind of workaround. There's a better way now, and it is just this. So log on as a privileged user, and I'll create a user. Oops, drop user GL cascade. I'll create a user GL with no authentication. Interesting bit of syntax. And you can see in DBA users, he's got no authentication. You cannot log on as that user. What you will then do is create your objects in that account. You could do it as a user who has any privileges, or you proxy to it. So what I'll do is I'll alter user GL, grant connect through Scott. Remember, proxy authentication. Give GL quota on a table space. Right. And then I can connect straight through. Oops, need to give them a couple of privileges. Connect system/local. I do need to give him to give the user the ability. Oops, right click, copy, just a couple of privileges. So he does have the ability to connect. He can't connect because he's unauthenticated, but I should now be able to proxy to him, and because I've also given him resource, we can create all the necessary objects. And now I can create the objects in this account in his default table space, and nobody can ever connect to him unless he's been explicitly granted that proxy capability. Or if I created the objects as a user with the any privileges, I wouldn't even have to make that grant. So very useful technique, and it is more secure than the old way of doing it. In the old days of eBiz, one of the first things you would do after instantiating your eBusiness environment was immediately lock and expire the passwords in 200 accounts, which was extremely irritating. And this is a much better alternative. And that's the final point I wanted to go through. So to summarize, username and passwords. There are better ways of doing it.